Hey there, students. So you should have gotten the answers down for the birth of the universe questions. All right. And so those, again, would have gone on page 8 of your packet. Those questions right there. Okay. So what I want you to do is go to page 9, and we are going to start with the Big Bang student note sheet right here. So page 9. Now you're going to see in the PowerPoint, there's a lot more stuff written down than you have to write. For the most part, it's just going to be the colored words that are kind of colored, not in white, essentially, that you would need to write down, with the exception of the first one here. There's actually a choice that you can write down for your definition of a theory. But the other ones are going to pop up here. So it'll say when. Like, when did this part happen? So you'll want to look for that in the information, and then what happened. So I'll kind of point those out, but essentially it's the words that are colored that you're going to be writing down there. So let's start with looking at this right here. Okay, so my first part that I want you guys to write down, it says, what is a theory? So you can choose one of the options to write on your paper. All of these are very good explanations of the word theory. So you just have to choose the one that makes the most sense to you and write that down on the top of page 9, right above the boxes. So a well-tested explanation, the best explanation of a natural event, tested and supported with evidence, or the ultimate goal of science. Now, the first 3 kind of talk about, testing or explaining things. The last one is maybe not quite as, obvious as the other ones are, but it still is a good explanation for what a theory is trying to get to that, understanding that goal within science. So again, choose just one of those. If you really want to write down more than one, that's fine. Okay. So next I'm gonna show this movie here. It's about a 5-minute clip that explains, just kind of summarizes the Big Bang. So we have an idea of what that is about first before we go at it. So let's go ahead and watch that here.
Bang. The idea. The beginning of everything. The Big Bang. The idea that the universe was suddenly born and is not infinite. Up to the middle of the 20th century, most scientists thought of the universe as infinite and ageless. Until Einstein's theory of relativity gave us a better understanding of gravity, and Edwin Hubble discovered that galaxies are moving apart from one another in a way that fits previous predictions. In 1964, by accident, cosmic background radiation was discovered, a relic of the early universe, which together with other observational evidence made the Big Bang the accepted theory in science. Since then, improved technology like the Hubble telescope has given us a pretty good picture of the Big Bang and the structure of the cosmos. Recent observations even seem to suggest that the expansion of the universe is accelerating. But how did this Big Bang work? How can something come from nothing? Let's explore what we know. We can ignore the beginning part for now. First of all, the Big Bang was not an explosion. It was all space, stretching everywhere, all at once. The universe started very, very, very small and quickly expanded to the size of a football. The universe didn't expand into anything. Space was just expanding into itself. The universe cannot expand into anything because the universe has no borders. There is, by definition, no outside the universe. The universe is all there is. In this hot, dense environment, energy manifested itself in particles that existed only for the tiniest glimpses of time. From gluons, pairs of quarks were created, which destroyed one another, perhaps after giving off more gluons. These found other short-lived quarks to interact with, forming new quark pairs and gluons again. Matter and energy were not just theoretically equivalent, it was so hot they were practically the same stuff. Somewhere around this time, matter won over antimatter. Today, we're left with almost all matter and nearly no antimatter at all. Somehow, 1,000,000,001 matter particles were formed for every 1,000,000,000 particles of antimatter. Instead of one massive ultimate force in the universe, there were now several refined versions of it acting under different rules. By now, the universe has stretched to 1,000,000,000 kilometers in diameter, which leads to a decrease in temperature. The cycle of quarks being born and converted back to energy suddenly stops. From now on, we work with what we have. Quarks begin forming new particles, hadrons, like protons and neutrons. There are many, many combinations of quarks that can form all sorts of hadrons, but only very few are reasonably stable for any length of time. Please take a moment to appreciate that by now, only 1 second has passed since the beginning of everything. The universe, which has grown to 100 billion kilometers, is now cold enough to allow most of the neutrons to decay into protons and form the first atom, hydrogen. Imagine the universe at this point as an extremely hot soup, 10 billion degrees Celsius, filled with countless particles and energy. Over the next few minutes, things cooled and settled down very fast. Atoms formed out of hadrons and electrons, making for a stable and electrically neutral environment. Some call this period the Dark Age because there were no stars and the hydrogen gas didn't allow visible light to move around. But what's the meaning of visible light anyway, when there's nothing alive yet that could have eyes? When the hydrogen gas clumped together after millions of years and gravity put it under great pressure, stars and galaxies began to form. Their radiation dissolved the stable hydrogen gas into a plasma that still permeates the universe today and allows visible light to pass. Finally, there was light. Okay, but what about the part we didn't talk about? What happened right at the beginning? This part can be defined as the Big Bang. We don't know at all what happened here. At this point, our tools break down. Natural laws stop making sense. Time itself becomes wibbly-wobbly. To understand what happened here, we need a theory that unifies Einstein's relativity and quantum mechanics, something countless scientists are working on right now. But this leaves us with lots of unanswered questions. Were there universes before our own? Is this the first and only universe? What started the Big Bang? Or did it just occur naturally, based on laws we don't understand yet? We don't know, and maybe we never will. But what we do know is that the universe as we know it started here, and gave birth to particles, galaxies, stars, the Earth, and you. Since we ourselves are made of dead stars, we are not separate from the universe. We are part of it. You could even say that we are the universe's way of experiencing itself. So let's keep on experiencing it until there are no more questions to ask.
All right, so hopefully that gave you some background into what we're going to get into now. Again, a lot of things happened in a short amount of time, so that's what we want to kind of keep in mind here. So again, now we're going to be filling out this sheet here and answering either part of the numbers over here or filling this stuff in here. So the first step in the Big Bang is that kind of just the definition here, both 14 to 13, that number can vary a little bit. Billion years ago, all the matter in the universe existed in a single point in space and time. There's no light, no space, no time. So that's what they were saying in the video. It's hard to know what came before this. So here's number one, box number one. When did this inflation, this is what we call inflation, so the beginning of time, it happened at 14 BYA. BYA stands for billions of years ago. So again, you'll write 14 BYA in the when box, and in the what happened box, you'll write this, what's in green, the super fast expansion of energy and space. So we have this timeline here that we'll kind of follow along the bottom, and you can see how um, the animations will kind of come up here as far as what happens. So you can see that my star, not really a star, but this is just expansion of energy and space here that happen. So there's no stars yet because we don't have neutrons or atoms yet until number 2. All right, sorry. Yeah, hopefully you guys got enough time to write that down. Otherwise, your teacher can pause it. Okay, number 2 is protons and neutrons. So you have to fill in the word neutrons. Again, that goes right on that line there. Okay, now you'll notice that this is split up into 2 different areas or boxes. So what I'm going to show you here is going to go on the top boxes, and then I'll have something else for you to write on the bottom ones. So as far as when, we're going to write 1 second or 1 second old. And what happened here, formation of protons and neutrons. All right, so 1 second old, and then formation of protons and neutrons. And most of you are in chemistry or have been in or even food chem. I'm sure you've talked about protons and neutrons. So protons and neutrons are what forms the center of atoms. Electrons are what orbits atoms, and they have very little mass, but protons and neutrons are what gives atoms their mass. So after 1 second, it was cool enough after that very hot expansion for the formation of protons and neutrons. So you can see I have the animation showing protons and neutrons kind of coming together. Okay. So we have P's and N's you can see throughout here. So this is what you can write on the bottom box, 3 minutes. Okay, at 3 minutes, we have the formation of atomic nuclei. So the protons and neutrons clump together and form atomic nuclei. So again, atomic nuclei is the protons and neutrons coming together. So again, in the bottom half of that box, 3 minutes and formation of atomic nuclei. And you can watch the animation pull those together. And if you remember, there, depending on how many protons you have, that gives you a certain atom. So these ones that have no neutron with them are hydrogen molecules. Those are the first atom on our periodic table. And they are made up of only 1 proton, no neutrons. And these elements, the ones that grouped 2 protons and 2 neutrons together, have formed helium. Helium has an atomic structure of, on average, 2 protons and 2 neutrons. So you can see the difference between the hydrogen molecules and the helium molecules. Okay, so now we're on to number 3. Again, we're moving on this list right here. So you have your first, and it'll be, first elements. Sorry, that word isn't colored, but you'll want to write down first elements right here on that line. So first elements. So this is 379,000 years after the Big Bang. All right, so the hydrogen and helium nuclei started to, it finally became cool enough for them to attract electrons. Before that, the universe was still really hot, and these electrons, which are these orange dots around here, were still sort of floating around. And you can't have an atom without electrons. So you only have the nuclei of the atom, which they have positive charges, right? Because of the protons, neutrons have no charges. So as soon as it got cool enough, those protons started to attract electrons to them, as many electrons as they have. So if you have one proton, you'll attract one electron. If you have two protons, you'll attract two electrons. So you can watch that. Okay. So again, each of these hydrogen atoms attract one electron. Each of these helium atoms attract two. You can see that there. And they start, like I said, once the universe cooled enough, after 379,000 years, the electrons started to connect to those, but they always orbit around the nucleus. They're never, truly connected to them, but you can see that there. All right. And so you can see where we are in terms of the timeline, barely moved at all off the 0 mark here. All right, so now we're at number 4. Clumps of, this should be gas and dust. So you'll want to write that in here, gas and dust under number 4. Sorry, these words should be colored. I forgot to do that. So I'm going to start here on the bottom. As far as our time, this is how long ago it happened. So the clouds are pulled far apart from one another for 100 million years. So 100 million years you can write down for your time. And what we're talking about in terms of clouds is how the gravity has pulled hydrogen and helium atoms into enormous clouds of gas and dust. So that brings us to 100 million years ago. Or sorry, not 100 million years ago, but it took 100 million years to do that. All right. So again, at that point, at 100 million years, the first stars and planets are formed. Let's make sure you don't have to write anything. Okay, so number 5, you have, sorry, there's not a big enough answer space here, but you'll write down first stars and galaxies. First stars and galaxies. You'll just have to add some more space to that. So again, we're at the 100 million years. Kind of both of these things sort of happened together. If you remember when we did them on our timeline, we had them both at the same time. So the first stars and planets were formed. You can watch the animation here. So again, it's what ends up being stars as combinations of hydrogen and helium, and that's still true today. Most stars are made up of that, including our own sun. They don't all have the same amount of hydrogen and helium, which gives them different sizes, different ages, also make their sizes different. So these clusters of stars will become galaxies. And within those will make the first planets as well. So this is a picture similar to what was in the video. It's kind of this bell shape, that happens here. So you have a very tiny beginning and then it sort of just balloons out right away. This is that cosmic radiation. You have inflation. Then you have your first stars here forming at that location. And then galaxies start to cluster together and whatnot. So this is all expansion. as it takes place over the 13.7 or 14 billion years. We're gonna skip that, I think, here. So, that's all I'll have you guys do for today. If you needed to go back and um, take a look at anything else, you could have your sub just rewind anything that you needed to.